Good. Yeah, welcome back, students. So yesterday we have discussed about all SAQs from different chapters, right? So I will say today what are the main important VSAQs from where you need to learn VSAQs. Okay. So first we will discuss VSAQs from the chapter. Only VSAQs are there. Like no other questions will come. Only VSAQs will come. Like few of the chapters are there, like magnetism and matter. From the two VSAQs will come. Only VSAQs, no other questions. And alternating current, electromagnetic waves, dual nature. This four chapters, we can say magnetism, matter, and alternating current, AC, EMW, electromagnetic waves, and dual nature. Dual nature of radiation, dual nature of radiation and matter. And one communication system. So these are the four chapters from which we can have only VSAQs. So in that, what are the questions which are important you see here? From magnetism matter chapter, you see if you have a material, you can just open and see that. Otherwise, just listen to me. Yeah. So in that one, what happened to the compass needle at the earth poles? Huh? No problem. That also will cover. See, so what happened to the compass needle at the earth pole? That we need to write the answer for that. Because earth pole, at earth pole, how the magnetic needle will be deflect? Because earth pole horizontal component of earth will be 0. That means earth magnetic field is 0, we can consider. So at that time, the needle can be deflect in any direction. Any direction. It can be deflect in any direction because the earth magnetic field is 0 at the poles of the earth. Okay. Because earth magnetic field is 0. Horizontal component is 0. Second, there is an important question is what is magnetic moment associated with the solenoid? What is magnetic moment associated with the solenoid? Solenoid magnetic moment means what? Basically, magnetic moment is M that is equal to I into A. I into A. Correct? So what is I? Current. What is A? Area. Area. Right? So simply magnetic moment I into A we can write. But in that, in solenoid, there are n number of turns will be present. N number of turns will be present. For single loop I into A, for solenoid n number of turns will be present. Ni A. N is a number of turns, total number of turns, and I is a current. A is the area of each turn. Each turn. Clear? Then what are the units of magnetic moment and magnetic induction? Magnetic moment is, from this only we can say, current into area, that is ampere into meter square. Ampere into meter square is a unit of magnetic moment. Magnetic field unit is Tesla. Magnetic field unit is Tesla. Moment unit is ampere meter square, and magnetic field unit is Tesla. Correct? Magnetic intensity or magnetic field, both are same meaning only. Magnetic intensity also Tesla only. Magnetic field strength also Tesla only. Right? So magnetic line of force continuously closed loop. Why? Magnetic field lines are continuously closed loops. Why closed loop means we know that it is a north, magnet exists as a north and south pole. They emerge from north and they will move across the outside and coming back to the south like this. Outside they will travel from north to south, inside from south to north, so that it forms a closed loop. Field lines emerge from north pole, enter at south pole, and travels from south to north inside the magnet. So that's the reason it complete form a closed loop. That is called it as magnetic field lines are closed loops. Clear? Define magnetic declination. Magnetic declination. What is magnetic declination means? Geographic meridian and magnetic meridian will be present. Nothing but magnetic meridian or geographic meridian means a vertical plane passing through geographic north and south pole, or magnetic north and south pole, we call it as geographic meridian, and earth magnetic meridian we call. But these two planes, magnetic meridian and geographic meridian, these two planes normally inclined at certain angle. Generally like this will be present. Like this is magnetic geographic meridian, and this is this one plane is geographic meridian GM, and this is another plane is magnetic meridian. Both angle inclined at an angle theta. That angle theta only we call magnetic declination. We call the angle between the geometric meridian and magnetic meridian is called angle of declination. Angle of declination. And the second next question, immediate question is there. What is magnetic inclination or dip? Angle of dip or inclination we call. What is angle of dip means? In this magnetic meridian, magnetic field of earth will be present. Magnetic field of earth will be present. So generally magnetic field of earth like this will be present. Here B, and this side horizontal component BH will be there, and this side vertical component BV will be there. The angle between net magnetic field and the horizontal component. The net magnetic field and horizontal component of Earth is called dip angle or angle of inclination. It is an angle between net magnetic field of Earth to horizontal component of field. We call it as angle of dip or inclination. It is denoted by pi, or declination is denoted by theta. Clear now? So one more thing is classify the following material with regard the magnetism. Regards the magnetism means there are three types of materials are there, right? Ferro, para, dia. So some of the examples are given here, like manganese, cobalt, nickel, bismuth, oxygen, copper. So from which is belongs to dia, para and ferro, we need to say. So from this simple we can say that nickel, cobalt are ferromagnetic material. They are nickel and cobalt are ferromagnetic material. Bismuth and copper are diamagnetic material, and rest manganese and oxygen are paramagnetic material. What is ferromagnetic material means? No, it is permanent dipole moment will be present. Dia, there is no permanent dipole moment, and temporarily that is opposite to temporary dipole moment will get, but it is only opposite to external field. Paramagnetic material, temporary field will come or temporary dipole moment will come along the direction of electric field. That is no need to write here, just classify into para, ferro and diamagnetic material. So in that I said copper and bismuth are dia, and oxygen para, nickel, cobalt or ferro, like that we have to write the classification. Clear now? So these are the how many questions we have discussed? I think 7. Correct? 7 questions. If you perfect, so obviously 2 questions you can answer from this. If you are perfect with all the 7 questions which I explained briefly, if you perfect all theoretical answers, only nothing numerical are there. So 7 questions, if you perfect 2 questions, can you answer easily? You can answer. Clear now? Yes. Now we'll see some question from AC, alternating current. Alternating current. So what are the VSEQs from alternating current? You see, what type of transformer is used in the bed lamp? Generally, they will give what type of transformer used in the 6-volt bed lamp. Means normally bed lamp is very small, voltage will be there. Okay, 6-volt bed lamp you want to light up means we are receiving to our home 220-volt power supply. We are receiving from the electricity board. 220-volt we are receiving, but to light the bed lamp of 6-volt, 220-volt directly we cannot give. So we need to reduce from 220-volt to 6-volt. To reduce from higher to lower means step down or step up we have to use. Down means higher to lower, up means lower to higher. So 220-volt we are receiving, but required 6-volt only. That means we have to reduce the voltage, that is step down transformer we have to use to light up bed lamp of 6 volt. We need to use step down transformer. Then next question is given. What is the phenomena involved in the working of transformer? Or we can say simply principle of transformer. Principle of transformer, you know that in transformer, primary and secondary coil will be there. In this like transformer, this side primary coil will be there. And here will be have secondary coil. Here the secondary coil will be there. So secondary and primary coil means what? It is a phenomena of electromagnetic induction. In that only 2 coils we are using. So it is a concept of mutual induction. Mutual induction. So principle of transformer is works on the principle of electromagnetic induction. In that mutual induction we can write. Then what is the ratio of transformer? Ratio of transformer is, here number of primary coil is NP, number of secondary coil is NS. And this we can write number of primary coil NP by NS will be equal to VP by Vs. This is ratio, we call it as ratio of primary to secondary voltage ratio will be equal to primary to secondary number of turns ratio will be equal. This ratio we call it as transformer ratio, we call transformer ratio. Another question is, write the expression for the reactance of inductor and capacitor. Capacitive reactance and inductor reactance expression we need to write. Simple. Capacitive reactance XC, inductor reactance is XL. This is 1 by omega C, and this is simply omega L, where omega is the angular frequency of alternating source. Angular frequency of alternating source. Simple, direct expression it is. And the one of the last important question from this chapter, you see, a transformer convert 220 volt AC into 2000 volt AC. Calculate the number of turns in the secondary coil. Primary as 10 turns. Transformer convert 200 into 2000 volt. 200 means VP will be 200 or Vs will be 2000. That means 200 voltage is converting into 2000 volts by using a transformer. That means primary voltage or input voltage is 200, secondary voltage or output voltage is 2000. And they've given primary number of turns are given is 10. Then secondary number of turns they are asking. Simple. Before that one question is given, what is transformer ratio? From that only we can find what is number of turns in secondary coil. That is NP by NS is equal to VP by Vs. VP is how much? 2000. 200. 2000 is a Vs. 2 ones are 2 tens are. From here NP is given 10, NS we need to calculate, that we got it as 1 by 10. Then implies number of turns in secondary coil will be 10 into 10 will be 100. Number of turns will be 100. So that is what we called the question related to this. So there are 5 questions are there from the chapter are important VSCQs. One is this question. Second one is expression for capacitor reactance, inductor reactance, ratio of transformer, What is the principle of transformer and what type of transformer used in bed lamp? All are simple questions only. Step down in bed lamp, ratio of transformer is this one. Inductance, sorry, capacitor and inductor reactance is this much. Final numerical question this much. Clear from this chapter? So these are simple questions only. I'm explaining the orally every question which are important. Yes, CQs. So answer you can go through your material. Okay. Next, electromagnetic waves. VSAQs from electromagnetic waves. From electromagnetic waves. So questions are theoretical question like what are the applications of microwaves? Microwaves. Uses of microwaves, you know, it is used in the navigation in aircraft or radar signals. Radar communications or aircraft signal purpose, we can use that microwaves. And even in micro oven also we can use that. Food items to heat up, we'll use the micro oven, right? In that also we will use microwaves. Then other question is given reverse of that only, that microwaves are used in radars. Why? Or why are microwaves used in the radars? The reason we need to write for why the microwaves are preferable to use as radar signals or radar communication. Purpose of radar communications that as microwaves will use means so microwaves, obviously, you know, that have some small wavelength, shorter wavelength, they are there, and they are electromagnetic waves, we know well. Shorter wavelengths are there, they can travel while traveling through a medium, they cannot bend around a obstacle in the medium. So because of they bend around the obstacle of the medium, maybe other phenomena will be takes place. So due to that, these microwaves, they cannot bend around the obstacle when they are traveling in a medium. So that's the reason we are using or preferable to use the microwaves as radar communication systems. Clear now? Because you have to write the reason for that. They are traveling in a medium. While they are traveling in a medium, they cannot bend around the obstacle present in the medium because of their shorter wavelength. Because of their shorter wavelength. This much reason you need to write for that is enough. Next one, give two uses of infrared rays. Infrared rays, you know, many of them we are So next chapter, that is dual nature. From dual nature chapter, we can say few important questions we'll see now. VSAQ, it's exclusive VSAQ chapter it is. So first of all, first question is, what are cathode rays? Cathode rays. What are cathode rays mean? Cathode rays nothing but it is electrons. A beam of electron, or we can say simply we can say cathode rays are the a stream of electron, a stream of fast moving electron we call cathode rays. The stream of fast moving electrons we named as a cathode rays. Simple. The next one is, what is work function? Work function is, basically in dual nature we'll study about whenever light energy falls on metal surface, there is ejection of electron will be takes place. Emission of electron will be takes place. So that process photoelectric effect we know. In the work function, what is work function means? Minimum energy required to eject an electron, to emit an electron from metal surface. Minimum energy of photon should be fall on the metal surface to get or to emit an electron from metal surface is called work function. Work function is minimum energy of photon should be fall on metal surface to emit an electron from it. That is called work function, generally denoted by pi, and it is denoted by h nu naught, where nu naught is the minimum frequency or threshold frequency we call. Threshold frequency. Next, there is a definition of photoelectric effect. Directly, just now I told, photoelectric effect definition is what? The process of emission of electron from a metal surface when an photon is falling on it, when suitable photon of energy is falling on the metal surface, the electron emission process we call it as photoelectric effect. Clear now? Once again, I state the definition. I'll repeat. You see, the process of emission of electron from metal surface whenever a suitable energy of photon falling on it. Clear? That is photoelectric effect. So next one, they give example of photosensitive substances. Why are they called so? Photosensitive substance means from which we can get a photoelectric effect. The surfaces from the substances from which photoelectric effect can be possible are called photosensitive substances. Generally, metals, alkali metals, or the act as a photosensitive materials because of they have low work function. Because you see, every metal you can consider, but in that some of the metal which has low work function is less because energy required is less. So easily emission of electron can be takes place. Easily emission of electron can be takes place. So that's the reason the metal which has low work functions are called photosensitive substances. We can call. Clear? Write down the Einstein photoelectric equation. Write down equation. Einstein photoelectric equation is the total amount of energy falling on the metal surface is utilized by two ways. One is to work function W. Second one is change in second one is kinetic energy. This can be written as the kinetic energy can be written as E minus W. So kinetic energy also we can write not EV naught, and E is H nu minus H nu naught. This is Einstein photoelectric equation we can call. In this one, V naught is topic potential. stopping potential, or nu is the frequency of incident photon, or nu naught is a minimum frequency of metal surface, threshold frequency we call. This is what we call Einstein photoelectric equation. Write down the de Broglie relation and explain the terms. Write de Broglie relation. De Broglie relation is what? Wavelength lambda is equal to h by p, that is mv. H by p or h by mv. Lambda is wavelength of matter. Wavelength of matter waves. And m is the mass of matter or mass of particle. And v is velocity. H is Planck's constant. So these are few important questions from dual nature. If you want to write Heisenberg uncertainty principle, what is the Heisenberg uncertainty principle? At a time, position and momentum cannot be measured. It is not possible to measure position and momentum of a particle at a time. It's not possible to measure the position and the momentum of a particle at the same time. That is called uncertainty principle. Heisenberg uncertainty principle. So these are some questions. Clear now? So last one from only BSAQ chapter is, that is communication system. The communication system, only 2 or 3 questions are there. I think when learn about one question is define different types of modulation. And there is a, what are the black diagram of communication system is there. Or maybe some uses of skywave propagation or ground wave propagation uses they will ask, right? Anyway, we'll see what are the questions are there. So there is a first modulation. What is it necessary to do modulation? Modulation is a process of inserting of higher low frequency carrier wave to the higher frequency of carrier wave. So combining the whatever we are developing a source which has low frequency, which has combinedly overlap with the high frequency carrier wave, we call it as modulation. It is a combination of or merging, we can say, merging of lower frequency of source into a higher frequency of carrier wave is called it as modulation, we call. And what is the need of modulation? Necessity of modulation means our content which is developed at a different source to want to send to a different places. Our developed content is very small frequency will be there. If you send directly with that frequencies, so they cannot travel long duration, long distance they cannot travel. So little bit distant travel, after that the frequency will be reduced or that cannot be detectable. So they cannot travel for long distance. So that's the reason you want to send your content for longer and longer distance very safely and with minimum loss of energy. Then we will use another help carrier to carry this content. So higher frequency of carrier we will use. So that is only need of modulation. Need. Otherwise, if you not do modulation, our content cannot travel for long distance. Our source of information cannot be moved long distance. Clear? The other important one is mention the basic methods of modulation. So there are three types of modulations are there. One is frequency modulation FM, amplitude modulation AM, phase modulation PM. Frequency, amplitude, phase modulation FM, AM and PM we call. These are basic three modulation we have. So mainly these are three questions are important from this chapter. Clear? So from others, these are the 4 chapters. From dual nature, you will find out 2 VSAQs, and magnetism matter also 2 VSAQs will find. Then you will find out from communication system 1, electromagnetic waves 1, and alternating current 1. So from this you will find out 7 questions. 3 plus 2 plus 2, right? Yes. 7 questions of from this 4 chapter it will come. Remaining 3 questions it will come. One is from semiconductor devices, other from ray optics, other one from moving charges and magnetism. Moving charges and magnetism. So what are that question? Just I will read and try to explain all this. The other question from moving semiconductor will see first. So there is a many times they asked in the question that draw circuit symbol of PNP and NPN transistor. PNP and NPN transistor. Transistor means basically three terminals will be there. 3 terminals will be there. So in these 3 terminals, which are PNP or NPN. So main difference between PNP and NPN is only the direction of current. Direction of current. You see here. Like this. So here current, suppose if you take normally current flows from higher to lower, positive to negative. P and P. P means positive, N means negative, or P type, N type semiconductor we call. So generally P, N, P. Suppose if I take this is P, this is N, this is P. Then from P to N, the current flows like this arrow mark. And this will be arrow mark N, P, N. That is P to N current will flow like this. Arrow mark is towards N means NPN, towards N. PNP or NPN. Like this will be there. Simple diagram only need to draw. Or otherwise, we want to name like it as emitter, base, collector, emitter, base, collector. So if it is say it as a PNP towards base is there, and this is NPN towards emitter is there current. Clear? Next, what are the gates called? Which are the gates are called universal gates? Universal gates are the gate from which remaining all other gates can be obtained. By using the gate from which remaining all the gates can be obtained is called universal gates. In that NAND, NAND, NOR, NOR, and NOT, NOT. These three gates are called universal gates. Universal gates, simple. NAND, NOR, NOT are the universal gates. And what is PN junction diode? Defined depletion layer they are called. PN junction diode is a what? One P-type semiconductor, one N-type semiconductor are joined together. There is a junction will be formed and call it as PN junction diode. And there is a thin layer in which immobile ions will be there. A thin layer in which immobile ions will be there. N side positive ions, P side negative ions will be created, and due to that a potential barrier will going to be derived, and this barrier or that layer of having positive and negative ions we call it as depletion layer. Depletion layer. PN junction diode is a one P and N type semiconductor joined together, a junction will form, call it as PN junction. And due to this, an N side positive immobile ions, P side negative immobile ions will be created. And this layer of certain thickness, we call it as depletion layer, we call. Clear now? So these are few questions from this. And from moving charges magnetism, we'll see what are the questions are there from that also. So first question from moving charges magnetism is, what is the principle of moving coil galvanometer? Moving coil galvanometer. What is principle of moving coil galvanometer? Means simple. This galvanometer will works whenever a current carrying coil kept in a magnetic field, it will experience a torque. Any current carrying coil kept in a uniform magnetic field, it experiences a torque. So based on that principle, only moving coil galvanometer will act. And the other question may they ask, it is how a moving coil galvanometer can convert into ammeter. Ammeter. Simple, a moving coil galvanometer, a small resistor connected in parallel to the moving coil galvanometer, then it will convert it as ammeter. Simple. A moving coil, for the moving coil galvanometer, a small resistance shunt we call, that is connected parallel to the galvanometer, we call it as converted into ammeter. That galvanometer is converted into ammeter. Simple, you can write by connecting a shunt of, or by connecting a small resistor parallel to the galvanometer, then a moving coil galvanometer converted into ammeter. That's it. So similarly, how it convert into voltmeter? Same but little bit change in the definition. For moving coil galvanometer, high resistance connected series with the galvanometer. High resistance resistor connected series with the galvanometer, then moving coil galvanometer converted as a voltmeter. Low resistance connected parallel means ammeter. High resistance series means voltmeter. That's it. And there is other question they may ask, what is difference between voltmeter and ammeter? Voltmeter and ammeter. Simple. Ammeter used to measure current. Voltmeter used to measure potential difference. Ammeter is connected in series with the resistor. Voltmeter connected is parallel with the resistor. Ammeter has ideally zero resistance. Ideally, voltmeter has infinite resistor. That's it. 3 points is enough. To measure current, to measure potential. Connected in series with the resistor, connected in parallel with the resistor. Ideally zero resistance, ideally infinite resistor. Clear? So finally, from the ray optics, first question from the ray optics is define the focal length of the convex lens, or sorry, define the power of convex lens. Power of convex lens is, power of convex lens simply it is power P is equal to 1 upon focal length. The reciprocal of focal length of the convex lens we call it as power, or simply we can write F in meter लेना है यहाँ पे, or otherwise 100 by F in centimeter. Okay, so unit of power is diopter. D. Clear? Reciprocal of focal length of convex lens we call power of convex lens. Simple. Correct? So next question, what is dispersion and which color will be relatively more dispersed? What is dispersion? Which color relatively more dispersed? Dispersion means splitting of white light into 7 colors. Splitting of white color into 7 colors is called dispersion. Simple. Splitting of white light into 7 colors. Dispersion definition. In that, which one is more dispersed means, which one is more dispersed? Violet will be more dispersed. Violet will be more dispersed than the other colors. Clear? Because it has highest deviation will be produced in violet. And the next one is, what is myopia? How it can be correct? Or what is hypermetropia? How it can be correct? Myopia means what? Nearsightedness. That means a person can able to see nearby object, like reading a book or newspaper can be done very well, but seeing a letters on board which is far to them, or far object not able to see clearly. So that is myopia. The person who are not able to see far object very clearly is called myopia, and it can be corrected by using a proper power of concave lens. Concave lens. Similarly, hypermetropia. Hypermetropy is also a same, the person who is not able to see nearby object, like reading of newspaper, reading of a book, not able to read clearly. Nearby object not able to see, far object can able to see. So this can be corrected, or remedy for that one is convex lens, proper convex lens. Simple, you need to write myopia if they ask. The person who is not able to see far object clearly. And this can be corrected by using a proper focal length of concave lens. Enough. Answer. Next, hypermetropia. The hypermetropia. The person who is not able to see nearby objects. And this can be corrected by using convex lens. Clear? So these are the VSAQs from this chapter. Clear now? So which I have said today, all the VSAQs from all the chapters which are expecting. So if you read whatever the VSAQs I explain orally from each and every chapter, so at least if you read only what I said, the question from each chapter, I not said more than 4 or 5. From if I say from the chapter 5, I said before chapter 3 only I said, in the communication 2 only I said, like that, on an average 4 or 5 each 4 questions each chapter you take. So maybe 20 to 25 questions I think all there together. If you read this 20 to 25 question perfectly without leaving anyone, then at least 7 to 8 questions you can answer without any doubt. In exam, 7 to 8 questions you can attempt, or sometimes maybe 10 out of 10 also it may come. But at least I'm saying least possibility 7 to 8 questions will come out of 10 VSAQs. Okay. So this focus more on this questions and be prepared every question without leaving any question, and perfectly you do, so you will definitely you do a good score. Clear now? Whatever the LAQs and SAQs, and now today whatever VSAQs we covered till now, these many days. So just once again you have a time. So till maybe 1 week, more than 1 week time is there. So you just again revise. No, again twice, once and twice you listen the class again. Write on a paper, practice on a paper, but finally you make it perfect. At least a few questions we have explained, not every question. Okay, but by keeping in mind for small time, small duration, we explain which are very important for your exam. If you thorough with this all the question of LAQ, SAQs and BSAQs, definitely not only you will pass, you will be a good score will be. You will have good score also. Clear now? Okay. So this is today we will going to be end completely. Syllabus is also completed for your examination. Clear now? Right. Thank you. बच्चे हैं वहाँ पे, बच्चे लाइन पे हैं. Students, if you wish to ask any doubts regarding this, you can ask me now. Today's sessions, do you have any doubts? You can ask. All are VSAQs only, all are theoretical questions only, not right?
Sir.
Still you have any doubt, you can ask me.
Sir, I have a doubt. Sir.
Okay, good. So any furtherly you are getting any doubt, you can once again you can see the lecture by Once again, you can go through the YouTube and click on it. I can see that lecture till you perfect. So however you finally you need to make me perfect all the questions. Clear now? Right. Yeah. Connect in that. Do unmute it. Hello.
Yes, sir. Sir, I have a doubt.
Yeah, tell me.
Sir, what is hypermetrophy again?
Yeah, tell me. Tell me now.
Sir, what is hypermetrophy again?
Can you speak loudly? Your voice is not audible. What is
Sir,
hypermetropia, right?
yeah, yeah.
Hypermetropia, told you know that it is a one kind of defect who persons were suffering with not able to see nearby object. Like the person, especially students, if you see, they are not able to read the book properly. Book is very near to us only, but still they are not able to read the book very clearly. Or some students are not able to read sitting in a back bench, they are not able to read the board. For them who are not able to read the blackboard from last bench, it is a myopia. But the person who is not able to see nearby object, like reading a book, is not able to done properly. It is called hypermetropia. Far-sightedness we call. So that can be corrected by proper convex lens we can use, and that can be corrected. Clear now?
Yes, sir. Thank you, sir.
Okay. Any other? Okay, students. So best of luck your for exam. Okay, right.